So what is confidence interval? Range of values that is likely to contain my true population mean. This gives me the range of values that is likely to contain my or our true population mean. Instead of one point estimate, I am giving a range of values. This is a better, more accurate representation. Okay. So instead of giving a point estimate, I'm giving a range of values. Instead of giving a point estimate, as we saw in the sample mean. Okay. It gives a range of values with confidence level. What does confidence level mean? For example, if I say that I have 95% confidence interval, does this mean that there's a 95% probability of finding for example, if I have some population mean, right? So I'll give you one range. For example, average life expectancy. If I say that it is between 75 to 79, say this is my average, very tight, 75 to 79. Okay. So I say this. So does this mean that there is 95% chance of finding the true average life expectancy here? No, because the average life expectancy would be some number. Say for example, that will be 77.2 or something. Okay, that is my average life expectancy. Okay, average life expectancy. So I say that with 95% confidence that this will be so this is one point, and I cannot say that there is a 95% probability chance. Okay, with 95% probability, the chance of it is that it will fall in this range. The probability, okay, we give it for a probability distribution. For example, if I have a Gaussian like this, then I can say that if I have two values here which are plus minus 2 standard deviation away from on both sides, then I can say that my data will lie in this with 95% confidence interval. But only if my average life expectancy is a PDF. It's a distribution, but this is one value. So this is one value. This doesn't mean that this is a probability. With 95% probability, I can find it in this range. This is plus minus 2 standard deviation away from the mean, and I can find that way. And that is, it doesn't mean this. Okay, so what does this mean? Let me give you an example, and there is a slight difference, and then you will understand this. Okay, so it means that if we repeat the sampling process, many times, then 95% of those calculated intervals will capture or include the true population mean. So if I do it multiple times, say for example, if I'm capturing the mean, I'm doing this 100 times. So 95 times of that 95 confidence intervals will have my 77.2, and 5 confidence intervals may miss or may not include this 77.2. Either they may be less than this or they may be more than this. For example, if I have a confidence interval for this which is 72 to 75, this doesn't include 77.2, right? So I can have 5 such samples which is missing this. Or for example, I have one confidence interval which is like 78 to 81. Okay, so again this is higher than 70, so this is missing this. This is not having this. So I can have 5 such samples. If I take this 100 samples, so I can have 5 such confidence intervals which may not include my true population mean. That's what 95% confidence interval means. That if 95% in the long run, I'm telling 95 out of 100, but it will be in the long run. If I do it multiple times, then 95% of those calculated confidence intervals will include my true mean, true population mean. I hope that is clear. Let me give you an example. For example, let's say we are measuring the weight of some variety of dog, okay, some certain species of dog. So I'm trying to measure the true population mean of a species of dog. True population mean weight of a species of dog, and say that is 30 kg. We know this. Okay, we know this, and we have to see that the measurements that we are doing, whether using the confidence interval, whether we are getting it or not. Okay, so we want to estimate. We want to. What is the goal? Task or goal is to estimate mu, that is the population mean. Okay, using 95% confidence interval. Okay, let's see how we will do it. So say for example, I have a sample number. Okay, and then the sample mean, that is x bar for that, and then I have 95% confidence interval. Okay, and then whether this confidence intervals has this. Okay, does it have, or does it capture? Does it capture mu? Question mark. Okay, so this is 30 kg. We know this is not 36. Okay, so this is 30 to make it clear. So let's see. So what are my samples? So sample number 1, for example, sample mean is 29.8, and the confidence interval here is 28.5 to 31.1. So does this have my 30 kg? Yes, this is lying in this confidence interval range. So here I will say yes. Okay, so later on I'll do this too. So second one is 30.4, and the confidence interval here is 29.1 to 31.7. This is 95% confidence. And the third one is 31.5, where this is 30.2 to 32.8. Okay, and then there's a fourth one which is saying 28 kg, and this is on the lower end, that is 26.7 to 29.3, and so on, like this we have till 100. The 100th one is, say for example, this is saying the sample mean is 29.9. everything is in kg. Okay, kg, and this is also, the range is also in kg. Okay, this is saying that 28.6 comma, this is from 31.2. okay, so does this have 30 kg? Yes, this one also has, yes, 30. No, this is greater than 30, right? Just missed 30 by just. This is no, this is no, and again this is yes, yes. So if you see, this has 30 kg, this confidence interval has 30 kg, because this is 28, 30, 29 to 31, this has 30 kg, this range has 30 to 32.8, it is just beyond 30. So this has missed 30. So this doesn't capture, this confidence interval doesn't capture. Similarly, this 29.3 is the higher end, this has just missed 30 kg. So this confidence interval also doesn't capture my actual population mean, that is mu. This is my mu. So what I am saying is that 95% confidence interval means that 95. So if I do it in the long run, right, 95 out of 100 such samples will have true population mean, and 5 samples may miss. Okay, may miss. They may, like these 2 samples don't have this. Similarly, 5 samples may miss to capture the accurate true population in the given range. That's what 95% confidence interval means. I hope this is clear now. Okay, so for normal distribution, so let's see, give me your formula for normal distribution. So for normal distribution, what do we do? What is the formula for normal distribution? Normal or Gaussian? Both are same. Normal is Gaussian, and you just keep on repeating so that it gets into your head. Normal, so we know that the rule 68, 95 and 99 rule. So there is 95.4 and this is 99.7, but okay, so this is this is plus minus 1 standard deviation, this is plus minus 2 standard deviation, this is plus minus 3 standard deviation. So the data will lie between if I have this mean again, if I do this bell-shaped curve, and I have, say this is the mean, and say this is one standard deviation, like this, one standard deviation, this is minus one standard deviation, this is plus one standard deviation this side. So my 68% of my data okay, 68% of my data will lie here, that is 34% here and 34% on the other, because this is symmetrical. This is minus 1 sigma, this is plus 1 sigma. Similarly, if you go minus 2 sigma till plus 2 sigma, and then this will be plus 3 sigma here, and this will be minus 3 sigma. So till here, this value will become 95, this complete graph, and then till here it will become 99. What is this captured? And this is a PDF, right? So this PDF will be equal to 1, or that will be like 100%. But this is very useful to understand. Okay, I'll just reiterate this. Okay, so what is the formula for confidence interval for normal distribution? So my CI is equal to the sample mean plus minus okay, plus minus Z is plus minus. Okay, just let me check. And let it be Z into sigma by root n. What is Z? This you know. This is a sample mean. This confidence interval. Z is your Z score. Z score corresponding to whatever confidence interval corresponding CI. So for example, if I want 95%, so this is 95.4. 2 sigma is 95.4. So if I give plus minus, if I want 95.4% to be my confidence interval, then I'll give plus minus 2 sigma. So my Z will be 2 here then. If I want to capture 95.4% confidence interval, so my Z will be equal to 2. If I want to capture 99.7, my Z will be equal to 3. So that is the corresponding Z score. If I want to capture 68% confidence interval, my Z will be 1 plus minus. Okay, that will be 1. This is what it captures. Sigma is the population standard deviation. So let's write it. Sigma. This is your population standard deviation, and this n is your sample size. Okay. So this is your confidence interval. I think all the concepts are clear. Now quickly let's see an application of this so that the concepts become even concrete. So let's do a question. Okay, for example, let's do a question. So the question is, I have 2 companies and I give you salaries of 2 companies, and now on the basis of that salary information that I have, I ask you to determine which company is offering you a better salary. If you have 2 offers in hand, which one will you join? Okay, and then that analysis you have to make. So let's do it. And then now you have got the tools of statistics, and based on that knowledge that you have acquired, I think you should be able to make a better decision. Let's see. So you have to suggest to some friend that suggest which company A is better. Okay, based on the details of the salaries. So the details of the salaries, I'll give you details of the salaries based on sample size of 50, based on n equal to 50 people they surveyed, and I have 2 companies. Okay, so I'll give you company. Okay, and then the average salary x bar, and then I'll give you standard deviation. This you have to. Okay, these information you have. So company, so there is one company A, there is one company B. One is giving you 36 lakhs, one is giving you 40 lakhs. Okay, LPA. The standard deviation for this is say 7 LPA, and for this is 14 LPA. So on the basis of this information, you have to tell me with 95% confidence interval that which is a, we'll use that tool to come to that conclusion, which pay is better. So on face value, it looks that this is way better. This is the only 90% of this, right? But this B is paying better, and there is nothing to think about it. So this 40 is better, directly go for it. But when you do more maths and more statistics behind this, then you will know that this is not as good. This shows that this is 4 lakhs difference, and there's no brainer that I should go for this, assuming everything else is constant, right? Work-life balance, etc., quality of work. So let's not get into that. So let's find out. So how will we do? So we'll go for first company A. So this is called margin of error, the Z, and the Z value, the Z score. Okay, so Z score, I'll give you Z score for 95.4 was 2 standard deviation, and Z score for 95% CI, 95% is equal to 1.96. Okay, just slightly less. Okay, so with this information, let's calculate. So this is the formula, Z into sigma. So that is, this part is called margin of error. So I'll say margin of error for A, company A. This will be equal to Z into sigma by root n. N is constant for both. Z is 1.96, sigma is 7 LPA, and by square root of 50 is the sample size. So this will come out to be approximately this is 7, this will also be 7, approximately 7, so this will be 1.94. okay. Similarly, so what will be the confidence interval for A? This will be equal to what was that? So my mean average salary x bar plus minus Z into sigma by root n. So this will be equal to, my mean is 36 plus minus 1.94. This will give me the confidence interval. So this will be 34.06 to 7.94. okay. And then similarly for B, what will be B for B? Margin of error. Margin of error for B will be equal to Z into sigma by square root of n, that is 1.96 into 14 by square root of 50, that remains constant. So this is just a double of that, that will be 3.88. And my CI for B will be equal to x bar plus minus Z into sigma by root n, that is 40 is my average salary here, second one, yeah, plus minus 3.88. So this will come out to be, the confidence interval will be 95%, 36.12 to 43.88. okay. So 95% confidence interval for A came out to be 34 till almost 38, and this is coming from 36 to 43, 44. This is my 95% confidence interval based on the data that I have. You will see that there is a slight overlap. From the lower range of this, that is 36.12, to higher range of that, 37.94. These two values. So in this range, both of these companies' salaries are overlapping. So there may be a case, if you get on the lower end of this company, then you will get 36, and if you get on the higher end of this company, then you can get 38, almost 38. So you will end up getting paid more for this company than this company. So this is not outrightly that you can say that this company is paying better, because you have to consider the standard deviation also that into equation, and now you have the information of confidence interval, and the basis of this, now you will have more confidence to decide which company is paying better. I hope this helps. And now finally, what is the, why are we learning this? What is the application? Where is it used? What is the application of confidence interval? So generally, with respect to machine learning models, okay, so instead of giving one accuracy value, okay, that it is 88% accurate or 85% accuracy for any given data, we give a better way to give that would be that I give a 95% confidence interval. Instead of giving 1 point estimate, if I go and give my manager that instead of giving that this model is performing like accuracy of 85%, accuracy of ML model is 85%. Instead of that, if I tell that with 95% confidence interval, this accuracy is lying between 82% and 88%. If I say this, then this is a better metric to give your manager or whoever it is. They will appreciate it better that this is giving me 95% confidence interval, and this, I don't know if you have considered outliers, etc. So this may come out to be this. Okay, so this is a better metric, more confidence. Okay, and it gives better understanding of what we have done. Similarly, when we are doing A/B testing, even in A/B testing, this is used when we are comparing, okay, 2 or more versions of the product. Even then, we are using this confidence interval. So we'll calculate confidence intervals for each of the product, and we'll see that which product version is performing better, and that 95% confidence interval metric is better than 1 point estimate here. I hope that helps.